Hello and welcome to the KPI Institute's webinar, Data Analysis, a Complex Process. Make sure you master all of it. My name is Andrei Kostea and I will be your host for today, along with our presenter, Adriana. This webinar is part of a series of free educational materials that aim to enhance the knowledge and know-how of those interested, while also creating a bridge between us as a company and you, our public. The KPI Institute is a research organization specialized in business performance. It operates research programs in 12 practice domains, each linked to a certification course, ranging from strategy and KPIs to employee performance and from customer service to innovation performance. The KPI Institute continuously builds on its values of best know-how, data and facts and common sense to achieve its mission of integrating performance as a discipline through research, publications, and, what interests us today, through educational programs such as this webinar. Today, 12 years after the KPI Institute was created, we can proudly say that our products have reached professionals in 5 continents, and that our public comprises a worldwide community of 73,000 members online and 28,000 registered companies on smartkpis.com. Today's webinar aims to teach you the basics needed for someone fulfilling an analysis role, and it will be delivered by Adriana, PhD, a statistics expert with over 20 years of experience, out of which over 9 years represent private sector experiences working for multinationals, and over 6 years of government and EU project experiences using SAS, Excel, R, eViews, and SPSS. His key areas of expertise are business data analysis, decision model building, advanced statistics, and research analysis. Adrian is an experienced trainer and facilitator, having conducted numerous courses and having worked as a teaching assistant for Queen's University in Canada and assistant professor for the Academy of Economic Studies in Romania. Some of the organizations that benefited from his expertise are Ericsson, T-Mobile, Vodafone, AC Nielsen, Ipsos Interactive Services, the Fraser Institute, and the Ontario Ministry of Finance. Adrian is the author of over 25 research publications on data analysis and business modeling and is certified to deliver courses at the academic level. This presentation lasts around 30 to 40 minutes. Please feel free to ask any questions you might have during the webinar, as they will be answered at the end of the presentation in our Q&A session. Enjoy the KPI Institute's webinar, Data Analysis, a Complex Process. Make sure you master all of it. Now I would like to invite Adrian to begin his presentation.
Hello everyone, and welcome to the Data Analysis webinar. Data analysis is a process, and it's, for me, data analysis is basically not only a job but also a passion. So I would like to share a little bit of it and explain it, how it works. The agenda of today's webinar will be we'll be focusing around data analysis as a process with its main components that you will see. We'll talk a little bit about data processing and manipulation, because data processing and manipulation is very important for data analysis and not a lot of people know about this. Then we'll talk a little bit about statistical and econometric analysis methods that are basically the building blocks of data analysis at the step when you're getting insights and when you're drawing conclusions. Then data interpretation is another topic of interest, and it's very important because it's not it's not the work that you do, it's the way you present it and basically sell it further. And also I'd like to briefly talk about data analysis and its links with other data-related topics that are very hot these days. And at the end of the session, I would, and of course, during the session, if it's if there is something that strikes your interest and you want to know more about it, just feel free to drop a question, and I shall proceed with the first topic. Well, before I begin, I'd like to remind you a little bit about the learning objectives of our data analysis programs. Basically, our programs are completely different than those from our competitors, because in this program, my aim is basically to provide a realistic picture of the data analysis process, how it actually is. Basically, another item that we as an institute would like people who attend our programs to gather is to acknowledge the importance of basic data processing and manipulation. Another topic of focus is to understand the role of mastering statistical tools and techniques. And also, we use as a tool for a basic data analysis MS Excel, which is very visual and widely accessible and quite powerful. And of course, talk a little bit about the connections of this course with more advanced topics like big data, data mining, and statistical process control. So the first topic, data analysis as a process. Not everyone is aware of the fact that data analysis, it's not only confined to, finding, having some data and getting some insights. Data analysis actually requires, first and foremost, data collection and preparation. We cannot have data analysis without the data to analyze, and sometimes this is the most difficult part. It's the part when you get the data, when you realize that, data is not in the right format, in the format that you want or need, and you have to prepare it, you have to clean it, and you have to make sure that it basically represents, the processes or the phenomena that you basically want to analyze. Then it comes the exploration of data, because if you have the data, you have to have a picture about it. I mean, you have to have to know if you have missing values. You have to know the limitations of the data, because the limitations of the data are going to pose limitation on your subsequent analysis and conclusions, and so on. And here you can see sometimes at this step you see whether there are problems with the quality of the data, and you have to go back to square one. Then the third step, which is basically confounded with data analysis, is the analysis itself. Once we have the data, and once we are sure that this data is good and reflects the reality or business reality, we can proceed to do analysis. Sometimes very interesting things come out from analysis and point out to issues that are basically addressed in the first and second step, so you should be aware of it. Analysis means the whole data analysis process often means rework, and you have to be prepared for it. And after the analysis, after we hopefully manage to get some useful insights and have actionable findings, comes the last stage, which is basically results, reports, and recommendations. And this is very important, because it's important to do your work, but it's also important to basically share, promote, and disseminate your work. And this is basically the last step of the data analysis, and this is the entire process in a nutshell. Now, data processing and manipulation. Basically, this is the most tedious part, and sometimes it takes, it can take 80 or 90% of the analysis time. And basically, there are a few questions you need to ask yourself. Why is it important to organize data? Why an analyst has to do it? And why Excel? Why Excel? Because they're fancier tools that are used in data analysis that you will probably use in the future if you do more advanced work. Well, it's why it's important to organize data, because you have to remember that in, I guess, 99% of the cases, data is not prepared for the analysts to to handle it and to prepare it. So basically you have to understand it, you have to see the limitations of the data, and sometimes you have to manipulate it to get it into a form that is amenable for analysis. And most important, you have to see the errors in the data. You have to see whether you have missing values, whether those missing values are related, they actually mean something. So for example, missing values for bankruptcy may mean that the customer is in good standing. Here you begin to understand the data. And here, basically with the data processing and manipulation, you have to get a data set ready that you basically know and you're comfortable with. And why an analyst has to do it? Because in most cases, no one else unfortunately does. Basically, you get data from, in many cases, you get data from operational systems, and those operational systems are built to cater for operational needs. So because of this, you have to get this data, you have to learn it, and it's a learning, actually when you start working with a new set of data, it's a learning process, and no one can do this learning process as well as you do. Well, Excel is you know, some people don't really like Excel, but Excel is widely accessible. Excel has data processing and manipulation capabilities up to 1 million rows, and there are some extensions that actually allow you to work with higher volumes of data. But the advantages of Excel is that it's a very visual tool, and in terms of spotting problems and seeing, you know, having a look at the data, Excel is very easy to use. With other softwares, you have to write some commands and you have to look at them, and you have to basically do some coding in order to figure out whether there are problems with data. Whereas with Excel, you can just see it on the screen. So and also Excel at later stages, you will see that has statistical functions and add-ins that allow you to do basic statistical work and some of the advanced statistical work. So don't discount it. Just use it because in some cases it saves you time and it allows you to do a better job. Okay, let's talk a little bit about organizing data. Sometimes you get data in different formats, and even within that data, you know, formatting can be different. There could be, as you see in the screen, is an example of dates. Dates are usually a hassle, and data can come, you know, although it's basically one row, one variable, you can have multiple formats, and you will have to work with that. You will have to transform this data in order to be able to process it further and have a unique formatting for all the data fields. So in this example, we had to extract the numeric data that is in the dates that are in numeric formats. We had to extract the day, month, and the year. And in the case of the others, we just had to do text to columns and get from there day, month, and year. And then we had to reprocess it and put a date into a format that we want and a format that is used in our organization. So basically Excel is, as I said before, is very powerful, and in terms of organizing data, its power comes from the easiness to manipulate. Excel can import data in many formats. It's basically text, Excel, Access, HTML, and Excel can import the data that has like 1 million observations and quite a few columns. So basically for a regular data set, Excel is all that you need. I don't think you really need more. And basically there are a lot of formatting options available. as you saw in the example before, when we extracted the data components, day, month, and year, we had to recompose it. And Excel has functions for this. My favorite one is concatenate, where you can put several texts and numbers into one basically one variable. And also there are extraction functions with the right find. These are functions that search for the second one searches for a specific string, for specific characters, and basically you can flag with it whether such a sequence of characters exist. And with the right and left, you can basically select the first digits or the last digits of a string, of a text string usually. Well, data collection. Basically, when people talk about data collection, they think about collecting data themselves by deploying a survey or by using certain platforms that can basically generate data, but this is not restricted. Sometimes data collection means that you just go in your organization and ask for the people who can provide you with data and get the data from there. Then when you have the data, you will start with data preparation. At this stage is very important to have to make something like an inventory of the data, which has the following elements. You have to know the types of variables that you're processing, whether the variables are text, whether they're numbers, and whether they're dates, and so on. Basically, at this step, you have to know what is the range of values that you encounter. I mean, what is the length of the text strings, or for example, you have a variable on sales. You have to basically learn what are the values that you normally expect there, so that you are able to detect errors and clean the data for this abnormal values that can alter. That can basically alter your analysis. You have to look at the missing data, and the missing data does not mean that the data is simply missing in some cases. Missing data can tell you whether you have a problem in the data, whether some data is misreported, whether some data is just not processed correctly, and in some cases missing data has some meaning. Remember the example with the bankruptcy. If in certain cases, for persons in good standing, there is no data available, and this is normal, but you basically should know about this, and at this stage you're basically learning the data and its features. And of course, the type of measurement. The type of measurement is something a little bit more abstract, but it basically tells you which statistical operations you can do with different types of data. So for example, if you have something that we call nominal variable, for example, a list of jobs, most of the operations that you do, you can just summarize the number of people who have these jobs, and do a pie chart. With numeric data, you can do a lot more operations, but also with text data, you can also do a limited range of operation. After you prepare the data, there comes the step of screening and cleaning data. Basically, at this step, you have to see what are the errors in the data and decide how to deal with them. You want to exclude them, or you want to investigate them further, or you want to keep them there and flag them. That's really up to you, and it differs from case to case. And at this stage, you have to set up some analysis templates. Analysis templates, because you saw in the previous slides that data analysis is a process, and this process sometimes has to be repeated and rerun. And in order to be efficient at doing this, at rerunning everything, you have to have the templates ready, because rerunning will be smooth and without problems, and you will be able to replicate your analysis at a later stage. Well, data preparation. the purpose is to transform given the data that you have in a format that is amenable for your analysis. So for data preparation, you need to consider the following main issues. That you have a data selection criteria. Basically, when you get the data, that you select only the data you need. You don't take the entire data sets because sometimes they're huge and you don't need the information. So it's basically the observations, the items that you want to take, and of course the variables that are of interest. Then you have when you prepare the data, you have to have an error correction. It's basically a quick template that flags the errors and corrects them. At this step, you have to decide how to deal with special values. Special values can mean outliers, and sometimes it's also missing data. And you have to take a decision to flag them, to separate them, or just exclude them in some cases. At this step, you have to eliminate missing values. Of course, you eliminate missing values if you have no better alternative. Usually, it's a good practice to eliminate missing values, but in some cases, they actually mean something, and you have to do a little bit of research and know the data. Here you clean the existing data after you decide what you want to keep, and after you do all the steps above, all the actions that basically fulfill the steps and address the issues above. You have to clean the data, and of course format the data would be the last one. Once you get clean data, you have to rearrange the data in the format that you want. Basically, in some cases you need to sort the data. In other cases you need to put variables in a different order. In other cases you won't just want to remove the variables. And in some cases you need to aggregate data. For example, if you have daily data, and the daily data make no sense for your analysis. For example, you want annual analysis, you may need to aggregate this data and get an annual sum or an annual average for some data. Now, the third topic is statistical and econometric analysis methods. This part is not only confined to the analysis part at the beginning. This part, statistical analysis, is also used in the initial stages. In the initial stages, when you explore the data and you get a grasp of it. Some key statistical elements have to be known for each and every type of data that you basically want to analyze. Some basic metrics is what is the size of the data. For example, you want to know how many customers you have, or how many transactions, or how much money do you make. You want to know the minimum and maximum values, because these boundaries are very important in statistical analysis, and they're used further to explore the data and get a picture of it. And of course, what is the average values? Whereabouts the number of customers or the sales or the number of transactions lie, so that you are sure that you have a good data that provides a realistic pictures of the items that you want to analyze. Another dimension of the data is its variability, and basically statistics lies on two pillars. It lies on averages, and that basically tell you on average where the data is, and its variability. So basically here you have an example of variability. You have the sales of ice creams and diapers for a store chain. And basically you will see here that of course ice cream is a lot more seasonal compared to diapers. Everybody knows why. But while this is obvious, it is not obvious in here which sales are higher And another important thing is that we don't really know whether the difference between them matters, because you saw that the distribution of the data, the way it evolves through the months is completely it's completely different for this case. Excel has a data analysis tool. It's called Data Analysis Tool Pack, and it has to be installed. Basically, it has to be activated because every Microsoft Office package has it. So in this tool, if you install data analysis, you have a lot of analysis options. And if you trigger data analysis, one of the most useful is descriptive statistics that basically basically gives you statistical measures to get a good picture of the data. It tells you the elements, it tells you the average, it tells you the median, that is the middle of your distribution. It tells you there are some measures of variability, standard deviation, sample variance. You also have skewness that tells you basically if the data, you have more values to the left of the average or more values to the right of the average, and of course it gives you the minimum and the maximum. The two key dimensions of the data, average and standard deviation, can be used to test whether some characteristics about the population are true. Population is a statistical term, but basically you want to see things like, for example, are the average sales for one item equal or not to the average sales of another item. So basically, I gave you some examples there. Like for single mothers, you wanted to see if their average purchases per month are close to a certain amount or not. And this thing varies a lot with the variability of the data, because in some cases, variables are basically static, they don't vary a lot during time, but if you have a high variability, you want to make sure whether there is a significant difference or not. To test the significant difference, you have hypothesis testing. Hypothesis testing is basically an more advanced tool of statistics, and it tells you whether you have a significant difference between two averages or to standard deviation, and standard deviation is the measure of variability. Hypothesis contains a statement about a parameter, and often you compare two parameters from two distributions, from two data that you want to compare. And its practical use, it's more when we test the characteristics of the data. So MS Excel has two ways to do this. You can do it with the built-in functions, but the best tool is basically the data analysis tool pack, which has several statistical testing options. If you use the later, the results are going to be expressed in p-values, which give the significance level of the hypothesis testing. And basically, if the p-values are very small, you have a significant difference. And we call, in statistical lingo, we call we say that the alternative hypothesis is accepted, and we have a significant difference between the data we analyze and hypothesized parameters, or whether we have significant differences between two sets of data. Okay, what are the functions in Excel for testing the data? We have the z-test, we have the t-test. We have the t-test with two sample equal variance, because data can have the same variability, more or less. We have the test between two data sets that are completely different with respect to their variability. Just remember the slide that you saw with the sales of ice cream and diapers. And also we have the f-test when we want to test whether there is a significant difference in variability between the two data. Now, the t-test is the recommended one because the t-test accounts for the fact that, the less data you have, for example, 10, 15 observation, the more variable it's supposed to be, and the t-test corrects for this variability. I mean, it makes different data sets comparable, even though the results for two different data sets comparable, even though the number of observation, the size of the data is different. Here is where you have the hypothesis testing options, the t-test in the data analysis toolpack, and this is a standard output that basically gives you the metrics. Here I tested for the difference in income and expenses. I wanted to see if there is a significant difference between the mean. The mean itself is presented at the top, then there is the variance, that is a measure of variability of the data, and we see that variability is about the same. The mean, it's a little bit different. Then you have the number of observations, and this is very important because it tells you how many data points you have, and it tells you whether you selected all the data. Then you have the difference. We assume that the difference is 0 between the two. Then we have some technical terms, DF and t-statistics, that you will learn in our course if you choose to take it. And then you have the p-values. The p-values that basically tells you how significant is the difference. And the rules that are that these p-values should be smaller than 5%. If as in this case, they're bigger than 5%, then the difference between the two items is not significant. So the conclusion is that there is no significant difference between the averages of income and the average of expenses because their variability is very high. So if you see the difference, there is of course a difference because the average for the first one is 264 and the average for the second one is 283. The difference is only due to chance. Multivariate analysis takes the statistical analysis one step further, and it's basically the form of analyzing the relationship between two or more variables. The simplest tool is correlation analysis, which basically tells you how one variable changes with the change of another variable. Well, it's basically used to select variables for statistical modeling, for example, regression analysis and factor analysis. And of course, Excel has a tool for correlation in the data analysis toolpack that you will basically see on the screen. Of course, you also have a function, Corel variable 1, variable 2, but it's better to use the data analysis toolpack because it gives you like visual outputs like the output in this slide. Linear regression analysis can also be done in Excel, and it's a fancier method to quantify the relationships between the variables. It's basically one variable called dependent variable, y, at the left, modeled as a function of other variables, x1 to x2 to xn. And basically with such a model, you can model the evolution of one variable with respect to the changes of other variables. And with these functions, you can also, if you get a decent function that works, you can you can also do a forecast. Basically, you can plug in hypothesized values or real values of the explanatory variables and forecast the values of y using the regression coefficients. The regression coefficients that are noted with B0 through B, and the regression coefficients basically tell you what is the change of y if x's, the explanatory variables, change by 1 unit. Linear regression can be depicted like this. It's basically a linear relationship between the dependent variable, the y, the variable that we try to explain, and the explanatory variables is a straight line. It starts with the basic level represented by B0 in the slide, and then with B1, well, here is B2. Sometimes notations are different. There is one variable that is not related to any explanatory variable, which is the basic variables, which is the basic level of variable y. And then there is the rate of change of y with respect to the change of x, which is shown in this slide as MPC. The initial, well, this is a standard output of regression analysis. It's a lot of information, but the information is extremely simple because basically in practice we use only a few measures. We use the R-square. Basically it tells how much of the explained variable, how much of the variation of the explained variable is explained by the explanatory variables. In this case, we have three explanatory variables: download, upload, and bit cap. And the explained variables, it's subscription price for high-speed internet plans. So in this case, we only explain 41.6% of the subscription price based on these explanatory variables. And we also have p-values for the coefficients that you will see in the latest table in the screen. And these coefficients have the same interpretation as for the t-tests. And the interpretation is that if the p-values are small and with except to the bit cap they're very small numbers, then these coefficients are significant and can be used in the regression. And in this case we have one variable that is not significant, because, and again the significance level is 5%. In this case we have the bit cap, which has a very high p-value and therefore should not be included in the regression. All the other variables have very small values, and of course don't be scared about the E minus 42 and E minus 24, because this is a very small number. It's 10 to the power of minus 42 and 10 to the power of minus 24. Another tool is the residual plot. Not many people use it, but we do, because in the residual plot you want to see that you know, the errors, you know, the unexplained part. For example, in this case, the unexplained part is close to 58.4%. The unexplained part represents the error, and the error plotted on this graph should be random. Basically, you have to see a lot of points scattered around with no pattern. But in this case, you don't get that, because there are a few influential values that you see to the right that basically alter your results, and therefore you know that your regression is not correct with respect to the randomness of errors. All right, data interpretation. Then this is basically the last step when you basically disseminate your analysis result and you disseminate your research, and you get feedback on it. Basically, you have to present your results. There is no standard when you're talking about this. Every organization has its standards, and you have to, as an analyst, you have to adapt to it. Basically, but there are some key rules. The key rules is to make it simple. You know, to have results that actually make sense, because if they don't make sense, they don't believe it. In the case of the regression analysis presented before, results didn't make a lot of sense because the coefficients were extremely small. To make more sense of it, you have to convert the units of measurement, you know, to values that make more sense. That is basically to convert them in gigabytes and present the result in gigabytes. This is the standard way of presenting a regression result. Basically, you can plug, instead of writing a formula that not many will understand, you can just plug the variable names in there and put the coefficients, and here in this example is pretty explanatory. So a change in a download speed of 1, an increase of download speeds in 1, can bring about a change in the price subscription by 31 cents actually. Of course, this information has to be accompanied by information about the R-square, the goodness of fit of the model, that is how much of the variation of the subscription price is explained by the variables in the model, and of course the p-values of the coefficients to make to ensure people that these coefficients are significant. Well, there are apart from fancier statistical tools, there are visual tools that basically enable you to get a grasp of the data and make it and present a quick picture of it. Basically, you have the histogram here. The histogram basically gives you a pattern of the spread of download speeds that are organized by intervals, and Excel can do this for you, but you have to work a little bit with it. This is an option, and this is a standard way of presenting a distribution. Another tool that is recommended is the Pareto Charts, when you know that most of the outcomes are caused by just a few of causes, and this helps you organize the data, starting with the biggest causes and how much you can fix how much of the effects you can achieve with it. In our case, you can cut down excuses for being late by addressing the first two causes for being late, that is forgot to set the alarm and the no clean pants to wear. Other data topics are concerned with data dimensionality. Well, usually regular data set, there's no benchmark, and it depends with the organization, but there are two situations. One of them is that basically the data, you can get very few observations, and the statistical methods have to be applied with a lot of care, but fortunately there are statistical methods that can adjust for the fact that you only have a few values. And at the other end of the spectrum is the new concept of big data. Well, let's talk about small data sets. With the small sample sizes, we have the T distribution, that is the student distribution. Basically, it adjusts the calculations, and it takes into account very small sample sizes. And therefore, when we use hypothesis testing, I advise you to use always the t-test, because the results are similar to the z-test, to the regular tests that are done for data with regular dimensions. Basically, there is no difference between the two when you have a regular data set, but with a small data set, you can never go wrong with the t-test. Big data, that's a lot of fuss about it, and we're talking about three dimensions. We have to think about the volume. How much data do you have? Because you have to have the right capabilities. So you have to be prepared in terms of capabilities to handle it. How fast do you want to be processed? And what are the various types of data that you want to process? Is structured data or very often unstructured data? Statistical tools can help you set up some tools for for the use of your organization. And basically, with the data, more companies are harnessing the data in order to put them to use and inform decision processes. One example is to set up the control limits. Basically, the control limits are very used in statistical process control, and basically you set up you set up two limits, an upper limit and a lower limit based on the mean, the average of a certain process, and on the past known variation. The sigma is a symbol that it's a parameter of the variation, and this variation is adjusted for the sample size, is adjusted with the number of observations on which calculations are based, because we know that with smaller data sets there's higher variability. And here is an example of a statistical process control for call duration. The upper limit and the lower limit are based using the average and the standard deviations, the measures of variability. And what do we see from this chart? We see that, things were good until April. Then call duration just shot up to abnormal values, of 4, and then it reverted back to normality. We're not sure because of corrective measures, but we see that this type of chart captures this abnormal situations and flags them in real time. All right, so we're at the end of the webinar. We covered steps in data analysis. We covered data processing and manipulation. Also, we had a little chat about statistical and econometric analysis methods. We pointed out to the importance of data interpretations, and we provided links with other topics. So if there are questions from the audience, they're just welcome.
Thank you very much, Adrian, for your presentation. So, as Adrian has just said, if there are any questions right now, please feel free to address them. Well, seeing as there are no questions at this point, I believe this brings us to the end of our webinar. Adrian, do you have any parting messages for our listeners?
Well, what can I say? We'd like to, we hope that the seminar has interested you. We hope that it provided an overview of the data analysis, and I attempted to provide you a realistic picture of the whole process. And if you want to learn more, of course, feel free to contact our office, because we have data analysis programs, data analysis training courses, both online and offline.
Thank you very much once more for your presentation.
Thank you. Thank you for your assistance.
The KPI Institute appreciates your interest in the webinar Data Analysis, a Complex Process. Make sure you master all of it. Follow our websites and our social media channels to find out more details and to subscribe to our next webinar, Desarrollo de una arquitectura sólida de medición del desempeño, which will be held in Spanish by our colleague Doina Maltsev. Also, if you are interested in getting a certification granted by the KPI Institute on vital areas within the performance management discipline, you can explore our scheduled courses on marketplace.kpiinstitute.org. Thank you again for your participation and have a nice day.